Bismillahirrahmanirrahim. Assalamualaikum and good day to Dr. Siti Nurhaida binti Khalil and Dr. Muhammad Asri bin Yusuf. I'm Ahmad Faisal bin Azam, supervised by Dr. Shafiza bin Ahmad, will present my final year project 2, which entitled Concept Design and Analysis of Filament Extruder for 3D Printing. Since my last final year project has different title, I will explain back from chapter 1. So for introduction, we have background study, problem statement, objective and scope. Background of study. Since 3D printing have aggressively increased in recent years, people nowadays can create their own filament by customizing their own do-it-yourself or DIY filament extruder that have a lower price than the market. Instead of buying filament, they can make their own filament using this DIY filament extruder. For problem statement, increasing in plastic waste that affect the environment can be treated by recycling them. By using custom DIY filament extruder, societies can produce their own filament as well as save the environment. The purpose of this research is to investigate and study the mechanism and concept of the filament extruder, to design and own DIY filament extruder, to provide an analysis on the filament extruder parts. The scope of the project, the filament extruder is especially designed for PLA and ABS filament materials. The filament extruder will only be designed using SolidWorks software, analysis of computational fluid dynamic or CFD on die of the filament extruder, stress and shear analysis, and simulation will be carried out using ANSYS and SolidWorks software. The pictures in this slide show the single screw extruder. This extruder is a benchmark of a plastic industry. For filament extruder, the Lyman filament extruder is a baseline design for the open source 3D printer industry. Benchmarking. The extruder filament extruder is built in 2013 and it is available at a price of $335 or 1,379 ringgit Malaysia. It will create ABS and PLA filament and have a various diameter of filaments. For the second benchmarking, the Filabot EX6 filament extruder are a highly qualified extruder. The extrusion screw can be replaced and is available at 44,000 ringgit Malaysia. For methodology, project flowchart, potential customer and customer requirement, PDS, house of quality, morphological chart. This is the project flowchart for the research. The customer requirement is made on the last research studies that stated the customer requirements and information. The table shows all the customer requirements that have been stated. Product Design Specification or PDS describe the condition that must be satisfied in order to be competitive in product or method. For these filament extruders, there are 4 PDS, which is maintenance, safety, and material and portability. For the House of Quality table, there are 10 criteria and 10 engineering characteristics listed in the HOQ table. The highest score for this table is the cost to produce, which shows its importance in this design of the filament extruder. For morphological chart, first we have the housing material, housing design, hopper mount design, die shape, and coupling mechanism. There are three options for this morphological chart. Conceptual design. Concept 1 has a box-shaped housing using belt as a coupling and a custom 3D printed hopper or feeder. For concept 2, it used a wood-based stand, steel plate hopper and socket wrench coupling. Concept 3 used the same stand as concept 2, but it used the T-pipe extension feeder with custom bottle and belting coupling. For concept 4, it has a box-shaped housing using the T-pipe extension feeder with custom bottle and a belting coupling. This is the weighted decision matrix for the concept and the Pugh ideal selection method. The result of the weighted decision matrix and the Pugh ideal selection shows that concept 2 has the highest score for both selection, which says that concept 2 is selected to be a concept design and will be proceed to the final design. The detailed design of this filament extruder is created by using SolidWorks software. This is the final design layout where the filament extruder is being held by a steel plate stand. The product cost of this design, the total is only 154 ringgit Malaysia, which is a way more cheaper than the market filament extruder. If included with the electrical parts, the range of price will be between 200 and 500 ringgit. For the analysis, the parts that will be analyzed in this research is the socket wrench coupling and the end cap. This part will be analyzed using the ANSYS software for the stress, strain and shear analysis, and for the CFD analysis, it will be carried out using SolidWorks software. The socket wrench coupling. For the left side of the photos, the red part indicates where the force is put, and the blue part indicates where the fixed support is placed. This is the result. For total deformation, when a 2 Newton-meter torque is applied, a maximum value of the total deformation is 0.00048,356 millimeter, as shown in the diagram, which is at the red part of the diagram. The highest deformation occurs at the surface of the socket where the force is applied, and the smallest deformation occurs at the middle part of the socket, which experience less force. Maximum shear stress. As the force applied to the socket is torque, it experiences the shear stress. So, the maximum shear stress happens at the middle part of the socket, which is at 1.4679 megapascal. This is because the middle part is the critical part where experience shear force the most, as both of the end of the socket is rotate at different direction. Then the minimum shear stress occurs at the both end of the socket, which is at 0.16 megapascal only. For the end cap, on the left picture, the force is applied on the inner side of the end cap as the auger bit push the liquefied polymer inside the extruder. A 30 Newton force is used as it is the same as the force produced by torque that push the metal polymer inside the extruder. The fixed support is located at the thread tab of the end cap. This is because the end cap is attached to the barrel of the extruder by using this thread. Thus, the thread will hold the end cap at the end of the filament extruder and become the die for the filament extruder. The result for this analysis is a maximum value of total deformation, which is 7.8 times 10 to the power of negative 5 millimeter as shown in the figure, which is the red part. It shows the highest deformation occurs at the end of the end cap. This is because a higher stress occurs to the smaller diameter, and the smallest deformation occurs at the part right after the thread location, which is at 8.6 times 10 to the power of negative 6 millimeter, which experience less force due to a bigger diameter size, and it is located closest part at the fixed support. The equivalent stress. The yellow part in the figure experience the biggest von Mises stress, which is at 0.37147 megapascal. For the CFD analysis of the end cap, this is the temperature of the fluid. Assuming the temperature applied to the fluid is the same as the temperature to melt the polymer resin, which is the range of 150 degrees Celsius to 200 degrees Celsius. From the diagram, the initial temperature of the liquid is 169.25 degrees Celsius, and the temperature is slightly increased when it goes near to the wall due to friction between the fluid and the wall that have a higher pressure. The highest temperature, which is at 177 degrees Celsius, occurs at the edge of the inner side of the wall. This is because at the edge of the inner side of the wall, which is the red part of the analysis, have the highest pressure as the fluid is blocked by other wall of the end cap. For the velocity of fluid, the initial velocity that goes through the inlet of the cap is at 0.068 meter per second. As it goes to the smaller cross-section, which is at the outlet of the end cap, the velocity is slightly increased. The particular reason for this to happen because of the physics of the fluid, which is, as the area decreases, the velocity of the fluid will be increased proportionally as the consequences of the continuity equation. Thus, the velocity of the fluid at the outlet is increased to 0.6 meter per second proportionally as the cross-section area at the outline becomes smaller as shown in the figure. For the conclusion, the objective of the research have been achieved. The design of the filament extruder that is shown have a low cost budget, which is all the mechanical parts price is listed in the chapter 3, and it is a way more cheaper than the market filament extruders. For recommendation, others can optimize the cooling features by using liquid and use Arduino controller for accurate temperature and motor speed to produce the filament. That's all from me. Thank you.